SOHCAHTOA. What did the S stand for? Did you write this on your notes?
Sine.
Sine. Now
S-I-N-E.
yeah, it's actually spelled S-I-N-E. That's abbreviated on your calculator as S-I-N, but it's S-I-N-E, sine. And the sine is equal to, now it's a fraction, right? It's just a ratio of one number to the other. So what did O stand for?
Opposite.
The opposite side divided by the hypotenuse. All right, what did what did C stand for?
Cosine.
Cosine, and it's spelled like this, C-O-S-I-N-E. And that is equal to the adjacent side divided by the hypotenuse. So what do these two have in common, sine and cosine? They're both divided by the hypotenuse. And lastly is our T, which stands for, which is T-A-N-G-E-N-T. And our tangent triangle ratio is equal to
opposite over adjacent.
Opposite over adjacent. So how is that different from sine and cosine? Yeah, it actually doesn't use the hypotenuse at all. It's the only one that does not use the hypotenuse is the tangent ratio.
Sine, opposite hypotenuse sine, opposite hypotenuse sine, opposite hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse tangent, opposite adjacent tangent, opposite adjacent tangent, opposite adjacent long sides of hypotenuse, and the other two sides depend on which angle you're focusing on. Take one angle and look. There's one side that's the opposite. You can clearly see that there's also an adjacent side. Sine, opposite hypotenuse sine, opposite hypotenuse sine, opposite hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse tangent, opposite adjacent tangent, opposite adjacent tangent, opposite adjacent.
So down here we have this one, and this one. And I want you to write out what they mean. CSC stands for cosecant. Now look at sine above it. And what do you notice about sine of A and cosecant of A?
They're opposites.
They're not opposites, they're
Reciprocal.
reciprocals of each other, right? Because sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, okay? SEC is secant. And what do you notice about cosine and secant? They're reciprocals, so they kind of go together. If you know cosine is 3 over 4, what's secant? 4 over 3. It's just upside down, right? So really easy. And the last one is cotangent. And once again, that one's pretty easy to remember. Tangent goes with cotangent. So you will have to remember these, but other than just knowing that and being able to find the ratios, we won't do much with them until you get to pre-calc or calculus in later years, okay? So one thing, obviously the tangents go together, right? Tangent goes with cotangent. So if tangent is 4 over 3, what is this one?
3 over 4.
3 over 4, easy enough. Now the S's go together and the C's go together. Or sorry, don't go together. So you have to go against that. So sine actually goes with cosecant. And cosine goes with secant. So they don't match. The tangents do, the others don't. Okay? So you just got to remember that. Okay? Going on, make sure you have your calculator. Okay, first one, we're actually going to do some of these on our own. So, starting with the sine of j. So, if you remember, j, this is important because this is telling you the angle that they're talking about. They're asking about angle j. So, I'm going to put, Sierra, a little theta sign right there in angle j. That's just kind of a visual marker, so I know that I'm looking at that angle. Now, from j, look at the left side of your paper. What two sides does the sine ratio use?
60 and 61.
What two sides? What do we call those sides? Opposite over hypotenuse. Remember, SOH. S-O-H is how we'll remember that. Sine is opposite over hypotenuse. So from theta, first of all, which one's definitely, without a doubt, the hypotenuse? I don't even have to think about it anymore at this point. This is definitely the hypotenuse. Put a little H right there so you don't forget it. Is that ever going to change? No, it will forever be known as the hypotenuse. Now the other two are the ones that can change depending on where you put the theta. So if we're talking about angle J, what's adjacent to J? It's right next to it, but it's obviously not the hypotenuse. Paul?
11.
11. So I'll put an A right here, which means, what do we call 60? It's all the way on the other side of the triangle. It's not touching angle J at all. That's called the opposite side. Easy enough to remember. They are what they are. So now that we have identified O and H, what two numbers are those? 60 divided by 61. Now I know you really want to press that sign button on your calculator. You've seen it your whole life and you've probably never known what it is except for maybe a few of us. But we're not gonna do it yet. All we're gonna do right now is we're gonna put the ratio in our calculator. So I want you to put a squiggly equal sign. And I want you to round 60 over 61 to the nearest hundredth place. So what's our answer?
0.98.
About 0.98. That is the sine ratio as a fraction and as a decimal. Okay, now let's do cosine of j. So has theta moved, or am I still talking about the same angle? Okay, so where's theta at? Where do I put my theta? Mason, where do I put my theta? Angle j, that is correct, because it's saying cosine of j. So you're going to put a theta right here and in the corner. And that is equal to, now our trig function has changed. We're not talking about sine anymore, we're talking about cosine. So look at the left side of your page. Which two sides does our cosine? Adjacent over hypotenuse. Ka. So ka toa. Like a bird. A-H, not O-H. A-H. And that is, now theta hasn't moved, so our sides are all still the same. This was hypotenuse, this was adjacent, this was opposite. So what two numbers do we need this time? 11 over 61. Bye-bye. Now, does 11 over 61 reduce at all?
No.
No, it doesn't. So, just make a little squiggly equal, and let's give a decimal approximation, just like we did with our square roots. So 11 divided by 61 is about 0.18. Now, sometimes they'll ask you for the fraction answer, so you would say 11 over 61. Sometimes they ask you for the rounded decimal, so you say 0.18. Just depends what the question asks for. Okay. Now, try and do sine of k on your own. Haley, which two sides do we need? Sine uses...
opposite and hypotenuse.
Good. OH, so. S-O-H, so is how we remember that. And what happened? How is this different than the other two? Nathan?
That we switched the angle from angle J.
Yeah, this is really important. Don't look over that. K, our theta has moved. So I'm not talking about angle J anymore. Now I'm talking about angle K. So what's going to change?
The opposite.
Yeah, no longer is 60 on the opposite side. 60 is now adjacent to K. And 11 is on the opposite side now. So O and A change when the angle changes. So O is now what? 11 over What's the hypotenuse always?
61.
And what do we notice about these two?
It's the same.
That's kind of what when I paused the video and I said, what did you notice about cosine of j and sine of k? They're the same. So cosecant of k, so theta is here in k. So what is cosecant the reciprocal of? Bless you. Look at that down at the bottom right side of your page.
Sine.
Sine. So what I suggest doing first is find sine of k. So from k, sine is opposite, which is 11, over hypotenuse, which is 61. So once you know sine of k, what do you have to do to find cosecant of k? Flip it upside down. So our answer would be 61 over 11. Okay, that's how that works. So in order to use trig in your calculator for this class, you need to scroll down to the 7th line that said, oh, sorry, no, I'm back in algebra 2 mode. The 3rd line, and radians is another way to measure angles. You'll use that in pre-calc, but for this class, we always use degrees. So make sure your calculator has degrees highlighted in black, and it probably already does. But sometimes they get reset and it gets changed. Okay, so make sure it's in degrees, hit clear, and then go ahead and type in sine. And you'll see it already puts a parenthesis up there. A trig function is always of an angle. So let's say we know an angle is 52 degrees. Sine of 52 equals 0.79, right? And later on we're going to find out that that is equal to the ratio of their sides. That's the whole point
So
of
we
these
don't
trig
put the little, we don't put the little degree mark up.
If you got a different answer, your calculator was probably in radians. You're going to get a different answer because it's using a different measurement for angles. Okay.
I still didn't get the right answer.
So tangent of 65 degrees gives us a ratio of about 2.14. So you got?
Yeah.
So later on we're going to find out sometimes we know an angle. We can use that to find sides. Sometimes we know sides, we can use that backwards to find angles. So trig ratios help us find those things.